Good afternoon, everybody. We last Friday worked on some factoring exercises, and what we're going to do is take these same techniques with us from last Friday. And you remember what the techniques of factoring we used last Friday were? Okay, there was a bottoms-up method, which was quadratic trinomial factoring. Difference of squares, quadratic trinomial factoring, and one more. Okay, the first one we talked about, and that you always look at first, is called greatest common factor. Okay, so that's going to be, so you have the checklist, and so before you go to do any of these other things, you look for greatest common factor. And we're going to see that here. And then I kind of expanded this for the last class for eyesight purposes. Anyway, these are the techniques we're going to be looking at today, which are a little more advanced techniques. Now, difference of squares, this is what Jay mentioned, right? Perfect square trinomial, so Gabby mentioned that. And we're going to go into something called sum of two cubes and difference of two cubes. Another thing, and I don't think we're going to get here today, is something called factoring by grouping. So what I'm going to do shortly is hand out the sheet that we're going to be working with today, and we're going to resume to that point. And I'll see if I can find it here. I better be able to find it. This happens sometimes. Here it is. Okay, so we are here. And I'm going to demonstrate a couple of these. What I want you to do on the top of your paper, I want you to write down these two things right here. Sum of two cubes and difference of two cubes. Right here that I'm circling. Yeah, on your paper there. You can write on notes too. I don't know if I brought it up last time, but on your paper, because we're going to access these techniques here today. They're going to be necessary to what we're doing.
Is it going to be like the same thing as cube and so squared? Like the same thing as the difference of squares?
Well, it's a different formula here, because if you look at difference of, if this was a difference of squares, we would have a plus b times a minus b, right? But in this one here, we have a minus b times this thing here, right? And of course, with squared, you don't have a sum of squares, because that's not factorable. But a sum of cubes is factorable in this manner here. So those are the things we're going to be using. But always first you use what? Or try what? Greatest common factor, thank you. Okay, let's go ahead to our exercise sheet.
Like the exponents, are those twos or threes?
Yes.
These are threes here. These are threes. These are twos.
Are those two? Which ones are twos?
These are, this is a two, that's a two, that's a two, that's a two. These are 3's here.
What's the factor of it?
Okay. Let's go here. So for these, we're going to factor the polynomial or identify it as irreducible. So I think at least one of these, maybe two of these are going to be, one of these turns out to be irreducible. So for problem 1, what would we do first in this problem 1? What will we use first? I told you today, and Friday, and Thursday to look for first. Which is, in the case number 1, x. And x times what? X squared plus x minus 12. Now this x squared plus x minus 12, what do we call this thing here?
Is that a trinomial?
It is a trinomial, and what kind of trinomial? A quadratic trinomial. And usually, what you try to do with a quadratic trinomial is you try to factor it into two linear binomials. What are your factors of x squared? X and x. And so what's going to go next here?
Would it be
Plus 4 minus 3? Now Ben said plus 4 minus 3. I think he's right. But what I like to do even before that, I like to look over at this minus 12. So if this is minus, what does it tell us here? It means we're going to have a plus minus here. And now we ask the question, what two numbers, which, when multiplied together, equal negative 12, yet when added together equal 1? 4 and 3, or 4 and negative 3, thank you, Kim. Yeah, 4 and negative 3, and then you add them together, you get, so that's how you get it. And so is this fully factored right here? This is completely factored, okay, completely factored. Now, for problem 2, we have a cube here. And so we would try to factor this as a sum of cubes. And as you might recall, or you see on your paper, a sum of cubes, like if we had x cubed plus y cubed, we can factor this as x plus y times x squared minus x times y plus y squared. And so for this one right here, the cube root of x cubed is equal to x. And what's going to be your cube root of 5? Well, you don't get you get a decimalized version. You get 1 point something something, right? Did anybody do that? You know how to do that? Go to math, and then if you go to math 4, you get your cube root to 5. You get this 1.71 something or other, right? So 1.71 or whatever it is. So this one, by the standards of the book, we would call this one irreducible. And it's just because we couldn't find a integer square cube root of 5. So according to standards of the book, we call this one irreducible. Okay? All right. Now, for number 3, which technique do you think we'll try to use? Difference of 2 cubes. So we're going to see if these things here are, we have the cube root of each of these. So what's going to be the cube root of x cubed? X. What is the cube root of 125?
5.
It is 5. Who said 5? Gabby, yeah. Did you just know that, Gabby, or what did you do?
Well, I thought it was, but I went ahead and checked.
So she thought it was, and she checked.
Were you chewing bubblegum?
So, yeah. And these are the things that, this should be part of your mathematical literacy toolbox. You should know that 5 cubed is equal to 125. What is 4 cubed?
A lot.
4 cubed, you should know that 4 cubed is 64. What is 3 cubed? 3 cubed is 27. What is 2 cubed? 8. Now what is 6 cubed?
Let me think about it for a second. 72. No, it's more than that.
No.
Oh, snap, yeah, my bad.
16.
Wait, no, it is 72.
72 times 3. 72 times 3.
You want that one step, right?
Huh?
216. 6 cubed is 216.
Almost had it, dude.
Almost had it. And I don't remember what 7 cubed is. It might be 729 or something like that. I don't know what it is. What is 7 cubed?
343.
It's 343. Okay, I said I didn't remember what it was. But 1 through 6 cubed, those are ones that would probably be a good idea to remember, especially 1 through 5.
I don't remember Mr. GM.
Yeah.
5 should be a common one, and also 4 up through 5 you should know pretty cold.
Another warning.
All right. So now we can use this as a so what I want to do is I'm going to go ahead, given these numbers right here, I want to choose somebody to help me finish this one right here. And this one here, we're going to get Addie.
Go, Eddie.
Okay, it'll be Addie. Good job. All right. Okay, look at the formula that said difference of cubes. Okay, what is that? Using that formula here, what can we rewrite this as?
Something cubed minus something cubed.
No, look at the formula. Let's go back to the formula. Here's your formula right here,
I hate this so much, Mr. GM.
right?
Oh,
I just like this very much.
in parentheses, something minus something parentheses.
Yeah, what are those somethings here?
X and 5.
So x minus 5. Okay?
And then x squared plus x5 plus 5 squared.
Doing great.
Okay, so that's it.
Oh, good job.
Yeah.
Now, that wasn't that hard, was it?
He goes, okay.
I do not like this. That's it, please do not pick me.
He goes, that's it, you're going.
That's right, you're wrong.
You did it right.
So really it's just follow the formula, right? Just follow the formula, you can get it.
Basically, yeah.
Yeah. So what I want to do is go ahead and work out number 4. I'll choose somebody in a minute to do number 4.
Okay, so on this one, on this one, would you use the other formula or do you use the increment?
I would use a greatest common factor, and if you have to use a greatest common factor, you're not going to have a cubed anymore, right?
Yeah.
Yeah. So this requires a little bit of flexibility.
Okay, well, I'm confused, so I'll let y'all do this one. I'll figure it out.
So I'll
was thinking add 6 and multiply the 5. But it's gonna multiply 6. Yeah, I thought that had to
Okay,
add the
let's go ahead here.
Yeah, let's go.
Hey, Tom, hey.
all that extra credit.
Hey, you need to go buy a lottery ticket online.
Yeah.
What, okay, Peyton, what is the greatest common factor in this bunch here? It's x, okay? And so if you factor out x, what do you have left?
X two, sorry.
X cubed plus x plus 6.
You mean this?
Yeah, 5x plus 6.
Right? And so now, is this x squared plus 5x plus 6 further factorable?
Yes, keep it drawing down.
What is it going to be?
I don't know, I didn't get that far.
Just let give Peyton time to work this out. 'Cause he should be able to work this out.
You put just like 1x in the parentheses.
Like this?
Squared.
Okay. Okay, Peyton, let me ask you a question. What two numbers do you know which, when multiplied together, equal 6, yet when added together equal 5? How about 2 and 3? How about plus 2 and plus 3? Will that work? Yeah, it'll work.
He's so smart. I don't even think he deserves it. Mr. G did all that for him.
No, he worked, but see, Peyton, he worked with me, didn't he?
Good job, Peyton.
Yeah.
Brought myself on that.
How'd you get into it?
So go ahead and work on number 5. I'll choose somebody for number 5, and we'll work on number 5 here in a minute.
The greatest common factor is, yeah, I'm lost. I'm going to.
Okay, number 5, look for your greatest common factor first. It'll be a greatest common factor will be a number.
Oh, there'll be a number.
It's 3.
Yes.
Yeah, because 3 is a factor of 8.
3 is a factor.
Actually, it is not a greatest common factor thing. I take it back.
I think bad
Isn't
is
it?
I lied to you. There's not a greatest common factor on this thing.
Yeah, I don't know why I'm so bad.
I can
I don't know, I just forgot what it was. So what technique is going to be used here? A what?
Sum of 2 cubed, right?
Sum of 2 cubed, yes. Let's say sum of 2 cubes. I'll choose somebody in another minute.
Not me. Do it anyway.
Okay, and I'll give you a little hint on this one. Okay, cube root of 8x cubed is equal to 2x. And cube root of 125 is equal to 5, or at least so Gabby says. That's what she says. So if it's wrong, we blame it on Gabby,
That's what I'm talking about. Let's do that.
but it's not wrong.
There's only supposed to be one principal. Oh, never mind.
Okay. Do this.
Gabby, are you
Speed, you're
done?
stuck.
Wait, I forget, 'cause I think I No, I just got one.
And then
Please
it'll be
don't.
minus right here.
Hey, can you sing like a song for Jackson needs to do here?
Like what?
Well,
This?
then-
Probably do not, I don't know, but I'm
You never got to hear a song.
I have to look at the other part. Wait, so let me look at the other part. So for the substitute,
Have you-
have you worked on your
song? Oh, Forrest Rogers, the one that you were learning?
That song that you played for us last night?
The Ghost Riders in the Sky? or-
Yeah.
Yeah, to me, it's not that hard, it's remembering the words.
So it'd be 10x?
What was that?
Got it, you do it.
Okay, let's go here.
You do not get
I will choose,
How is it mine?
little mark.
Where do I put,
it's gonna be Bryce, all right.
Bryce.
Bryce is usually ready. Okay, Bryce, what do you got?
Alright, so I got that. And then I went and, so we do it like, just like we did 3, right?
I think so, man.
Yeah. And then it goes to 2x, right? And then minus 5 plus 5.
Okay, now square this guy here. 2x squared is what?
2x squared plus, or, yeah, plus
What's 2 squared? 4.
4x squared. That's what we got.
Okay, minus 2 times this,
10x.
or, yeah, it's gonna be 10x, minus 10x, thank you. Minus a times, x times y, and then what else? Plus
Plus, wait,
5.
yeah.
Is that it?
So,
That is it?
So, Mr. G,
Yes.
why can't you just put in parentheses 8x plus 5 and then outside of the parentheses cube it?
Yes. Go ahead and restate it. What's your question?
So 8x plus 5 and then put parentheses around it and put it to the power of 3. Why can't you do that?
It's not fully broken down.
Yeah, what happens is, if you go ahead and multiply all these out, you're not gonna have this.
So you have to cube the 8 here.
Yeah, it's like the most common error in algebra is this, like x squared, x. Are these equal here? No, they're not.
No.
Okay, so this is also a common, so what it is, it's the most common misconception in algebra maybe, that you can do that. So that's the answer to that. Okay, go ahead and do number 6. I'll choose somebody in a minute for number 6.
So this one's the sum of 2 cubes?
All right, number 6. Let's see who's going to do number 6 for us. It's going to be Gabs. Okay, Gabby, what do you have for number 6?
I'm not for sure, but on the greatest common factor, would it be 2x or just x?
Yeah, you have 2 factorable here too, right? So you have what?
Would it be x squared plus 3?
Is this any further factorable?
No.
No, it is not. That is good. That is it. That's as far as we can go.
Okay, which one did y'all use on that one? Which equation?
So was that fair to give Gabby an easy one like that?
No. I wanted that one.
'Cause I was
It's the
pretty
same,
sure
that's
about
the
it.
first one.
Guess it was hard because she wasn't sure about it.
It's the same as the very first one.
It was just too easy, right, Gab? Or you were worried it was too easy to be
Yeah,
trusted.
yeah, I'm not understanding.
Too easy to be trusted. You were ready for a snake in the grass, weren't you? But it was not a snake in the grass, it was a pussycat, that's what it was.
Yeah.
Okay.
I get that.
Okay. You ready for number 7? Or you need another minute on 7?
We're gonna need a few.
A few minutes.
Eight's the understand. You should put that right there for that one.
Holy macaroni.
Holy macaroni. Holy macaroni.
So, oh crap.
Okay, so this one, I'm gonna guess we're doing that, because
Okay, here we go.
I'm confused.
Number 7. Here we go.
it's gonna be.
That could be good.
Jade, oh,
Jade or Jacob, Jade or Jacob, Jacob.
Jacob, yes, sir.
Yeah.
Yes,
All right, Jacob, what, do you have any ideas about this one?
You should.
Have you been watching the videos, baby?
Yeah, you think it.
Do you find in here, Jacob, a greatest common factor? What is that going to be?
Yeah, it's gonna be.
Okay, I'll give you a hint, Jacob. I'll give you a hint. Greatest common factor is going to be 8.
It's eight, it's eight.
So now the next question is, what times 8 equals 216?
Hold on, give me a second, I will tell you.
Go on, Jacob.
Say it, Jake. 27. Say 27.
27.
27, thank you, Jacob. And then, so we know we're going to have x cubed here, right? And what times 8 equals 64?
6, right? No, they, yeah, they.
Okay,
Hot in here, okay? I panic when I get hot.
so now, yeah, so now we have, because it's just an advanced thing, it's just not, that's just the way it works out, okay? So now what's the cube root of 27x cubed? It's 3x, right?
Oh, yeah.
And what is the cube root of 8?
You can't cube 8.
That's.
What's cube root of 8? 2, right? So now we can work this out.
How do you know?
How do you know cube root of 8 is 2? That's just mathematical literacy. All right, Jacob, so now we have, what technique are we going to use? Sum of 2 cubes, right? So what's going to go here? Let Jacob do this, guys.
3x
Plus,
plus 1, 2, plus 2 buttons.
it's 2. Now here we have x squared, right? So if we square 3x squared, if we square 3x, what do we get? 9x squared. And then we're going to have, that's plus, so this is going to be minus a times b. So 2 times 3x is 6x plus 2 squared, which is 4. So is that our answer? Yeah, that's our answer. Now, nobody asked me today, yet. Somebody did in, it was Haley who asked me in the second period if this second parentheses 9x squared minus 6x plus 4 can be factored. Can that be factored?
Yes,
No, once you get to difference of cubes or sum of cubes, that trinomial at the end cannot be factored. So that's going to be an irreducible quadratic trinomial there. Okay, so I give Haley, when you see Haley, give her credit. Okay. Now, the last one we're going to look, in fact, it's probably going to be the last one we do today, is probably we're going to stay at 8 today. So I want you to work out 8. I'll choose somebody here in a minute to work out number 8.
That's at like 30 minutes. I'm gonna get on this one, so I can probably do this back.
I think I'm coming.
Ray's coming back here at 8, right? Stop pushing my
What's that?
I've been lost the whole time.
Okay. Well, I know the first part's going to be 8.
I think I don't think that's right. What I did, I missed it.
You use the difference of cubes formula for that. All right? Okay, difference of cubes. Here we go. You want to be AJ?
Let's go, Benny Z. Let's go, Ben.
Benny Z. All right, Benny Z, what do we got?
Okay, so you factor out the 8,
8.
that's x cubed minus 8.
Okay.
And that's a difference of squares, the difference of cubes.
Difference of cubes, okay.
So it's 8 parentheses x minus 2. That'll be x squared. Would it be plus 2x and plus 4?
Okay, does that look right?
Yeah.
Yes.
The thing, Benny's so fun to listen to because he always asks with a question mark. Like he questions if he's going to get it right, but he knows he got it right, but he frames it as a question. Like he's very polite about it. Like, no, that's right. Good job.
Good job, Ben. Like that.
So because of syncing with other classes, we're going to just wrap that up here today and just leave it right here, okay? And do that. Good.